must be a lion, not a mouse, if I only had the nerve. I'm afraid there's no denying, I'm just a dandelion, a fate I don't deserve. I'd be brave as a blizzard, I'd be gentle as a lizard.
Roar. Roar. Hairball. Hey, welcome back. It's the Science Geek. Today's objectives are to identify the components that make up a lipid, identify the types of lipids, and to understand the functions of a lipid. First, we're going to take a look at a couple of the characteristics of lipids. Lipids are nonpolar organic molecules and therefore do not dissolve in water. One thing I'd like to point out is the word organic. It means that it consists of carbon atoms, or it's made up of carbon. Lipids are fats. They could be solid or a liquid. A triglyceride, which is a fat that is a solid at room temperature, is called a fat. Whereas if that triglyceride is a liquid at room temperature, it is called an oil. Some examples of lipids are bacon fat, vegetable oil, butter, margarine, and wax. There are three main forms of lipids that exist. The first form is that it's a fat. Fats are made up of carbon, hydrogen, and oxygen, just like carbohydrates. The only difference is carbohydrates has a 1 to 2 to 1 ratio between carbon to hydrogen to oxygen atoms. Another form of a lipid is a phospholipid. Phospholipids are the main components that make up a cell membrane. Sterols are hormones, such as testosterone and cholesterol. The molecular structure of a fat is pretty simple. We have a glycerol head, which is made up of a 3-carbon alcohol molecule, so it's just carbon, oxygen, and hydrogen, as well as some fatty acid tails. These fatty acid tails, there's 3 in this one, are made up of carbon and hydrogen atoms. Fatty acids could be saturated or unsaturated. Saturated fatty acids have the maximum possible number of hydrogens. So if we take a look at this carbon chain, we have the maximum number of hydrogens surrounding that carbon chain. Whereas unsaturated fatty acids have double bonds within the chain and therefore have fewer hydrogens. So if we take a look at this area right here, because of this double bond, these carbons are missing 2 hydrogens. As I flip back to the previous slide, you should be able to tell a difference between a saturated and unsaturated fatty acid. This is a saturated fatty acid. Notice all single bonds. We have the full amount of hydrogens. This is what happens when there's an unsaturated fatty acid or a double bond in there. 2 of the hydrogens go away to make it unsaturated. When you think about saturated versus unsaturated, you could just think of a wet rag filled with water. If that wet rag is filled with water, it will start dripping. That means that it's met its capacity of water for that rag, just like a saturated fatty acid. If you have a part of the rag that is not saturated, meaning it can hold more water, then it's like this unsaturated fatty acid, where there's a double bond there, and it could potentially hold more hydrogens, but it would have to lose that double bond. Phospholipids are the same thing as a glycerol molecule, except that it adds a phosphate and nitrogen containing polar head. Alright, phospholipids are made out of a glycerol, 2 fatty acids, and that phosphate group. Phospholipids are the building blocks of cell membranes. We will talk more about phospholipids in our next unit on cells. A lot of us know that when you put water into a cup and you dump oil on top of the water, that will get two different levels and they will separate. The reason behind this is oils are made up of these glycerol heads and fatty acid tails. If we take a look at a phospholipid that makes up the cell membrane, and we dump a whole bunch of phospholipids into a water substance, we know that we're going to get that layer. And this is the mechanism behind it. The head of the phospholipid, which is the phosphate group in the glycerol group, is hydrophilic, which means it likes water. Hydro means water, philic means likes. So it doesn't mind going into the water. However, when you look at the tails are hydrophobic, meaning hydro meaning water, phobic meaning fear of. So it does not like the water. So the heads will stick into the water and the tails will be out of the water. And that's what causes that layer that you see when you dump water and oil into a container. This is a picture of a phospholipid and how it fits into the cell membrane of a cell. Phospholipids come together to make a phospholipid bilayer. If you look, we have two sets of phospholipids. The tails are in the middle and do not like water, and the heads don't mind coming in contact with water. What this does is sets up a semi-permeable membrane, which means it only allows certain things in and out of the cell, which is a very important function in regulation within the cell. We will take a look at this next chapter in more details. I just wanted to point out a phospholipid as a lipid. Sterols are also lipids. Sterols are more commonly known to us as hormones or steroids. Testosterone is a hormone found in males that is a lipid. Estrogen is a hormone found in females, which is a lipid. Cholesterol is found in both males and females, and there's different types of cholesterol. There's good cholesterol and bad cholesterol. Sterols are essential membrane components, and they form many hormones that the body needs in order to function. There are many functions of lipids. First and foremost, they are major components of cell membranes. They provide insulation for the body. They provide a protective covering, and they're involved in energy storage. Fat is stored in animal cells as large lipid droplets. I hope this tutorial is able to shed some light on what lipids are. Lipids are fats. They're made up of carbon, hydrogen, and oxygen atoms. There are many different types. Your fats are your triglycerides. Your structural components of cells are your phospholipids, and your hormones are sterols. There are many different functions of a lipid, including insulation, protection, the main component of the cell membrane, as well as storing energy. One of the biggest misconceptions that I see from year in to year out is that carbohydrates and lipids are often confused. Carbohydrates is now energy. It's the energy source that is used right now. Lipids are stored energy. Our body stores fats in order to have energy in case of an emergency or later on when all the now energy is depleted. If you have any questions on lipids, feel free to bring them to class, and be good, y'all.